Polynomial identities. Polynomial function is one that has powers more than one, so x squared plus x plus 3 or cubed, something that's cubed a fourth. So a polynomial function has powers. Okay. Number 0 is called the zero polynomial. The one with the highest power explains to us what type of polynomial it is, if it's cubed or quartic or whatever. A monic polynomial is a polynomial whose leading term has a coefficient of 1. So 1x cubed plus 3x squared plus 2. The constant term is the one without the x. Two polynomials are equal if they have the same value for all x. It can be proved that if two polynomials are equal, then they have the same degree and corresponding coefficients are equal. And here's some examples. So if ax plus b equals cx squared plus dx plus c, then c must equal 0, d is a, and e is b. This process is called equating coefficients, and we use that to help us solve. Example 1. If the expression a plus 2bx squared minus a minus bx plus 8 equals, and 3x squared minus 6x plus 8 are equal for all x, find the values of a, b, and c. So we say a plus 2b, shocking writing there, x squared minus a minus bx plus 8 equals 3x squared minus 6x plus 8. So here we have the squared, and here's the squared, so we equate those ones, and we equate the x with the x, and of course the number here and this number here are the same. So looking at the x squared, so equate coefficients. Gives us a plus 2b equals 3. Then we have, they're both minus here, so be aware of that. And that one's minus as well. So I'm going to write them both down. Minus a minus b equals negative 6. Of course, I didn't have to write that like that. I could have said a minus b equals 6. So we've got two equations which I'll number, 1 and number 2. And I'm going to say number 1, take away number 2. So I'm going to solve them, because if I take them away, the a's cancel, and I get 3b equals 3 minus 6 is negative 3. So b equals negative 1. So now I'm going to say, I'll do it over here on the side, sub b equals negative 1 into, and I'm going to sub it into equation number 2. So I get a minus, and a minus 1 becomes plus 1 equals 6. So a equals 5. So I found my values of a and b. Example 2. Express x squared in the form c bracket x minus 3 squared plus a bracket x minus 3 plus d. So we'll say let x squared equal c x minus 3 squared plus a x minus 3 plus d, which if I expand and collect like terms here, I'll get c x squared minus 6x plus 9 plus ax minus 3a plus d, and then putting them all together, I'll get cx squared, that's the only one, plus a minus 6c, that's both got an x in there, plus 9c minus 3a plus d. Okay, so therefore this c belongs to that one, so we get c equals 1. And we get a minus 6c equals 0. And we also get the 9c minus the 3a plus the d equal to 0. While this one becomes a minus 6 equals 0 because c equals 1, and therefore a equals 6. Now subbing a equals 6, c equals 1 in here gives us c is 1, we get 9, a is 6, 3 times 6 is 18, plus d equals 0. 9 minus 18 is minus 9 plus d equals 0. So d equals 9. So we found that d equals 9. Therefore, x squared equals 1 x minus 3 squared plus the a, which is 6. So 6 x minus 3, and my d we worked out to be 9. So we've transformed that. Example 3, find the values of a, b, c and d such that we get that. So just to save a bit of time here, I'm quickly just going to write that in the expanded form and collected. So we get ax cubed plus 6a plus b x squared plus 12a plus 2b plus c for the x, and then we've got plus 8a plus b plus d, and of course equating coefficients gives us a equal to 1. It gives us 6a plus b equal to 0. Therefore, b equals negative 6. And a equals negative 1. It gives us the 12a plus the 2b plus c equal to 0. But subbing in, a equals negative 1, b equals negative 6, gives us negative 12 minus 12 plus c equals 0, so c equals 20. A equals negative 1. Oh, it wasn't a equals negative 1, it was a equals positive 1. That becomes positive, c equals 0. And the last one is 8a plus b plus d equals 0, but a equals 1 and b equals negative 6. It gives us 8 minus 6 plus d equals 0, so that's d equal to negative 2. Therefore, x squared equals a was 1, so x plus 2 cubed plus b, so I'll make that a minus 6, x plus 1 all squared, c is 0, so don't even bother writing that, minus 2. Example 4. Show that 2x cubed minus 5x squared plus 4x plus 1 cannot be expressed in that form. Okay, so let's pretend that it can. 2x cubed minus 5x squared plus 4x plus 1 equals a x plus b cubed plus c. Okay, we'll expand the right hand side and I'll collect the like terms as usual, so I get ax cubed plus 3ab x squared plus 3ab squared x plus ab cubed plus c. And if we equate coefficients, we get a equal to 2. We also get 3ab equal to -5. A equals 2 gives us 6b equals -5. B equals -5 on 6. We also get 3ab squared equal to 4. But a equals, won't need that because we've got a and b. And the last one is ab cubed plus c equals to 1. Well, if I work this one out here with a equal to 2, I'm going to get 6b squared equal to 4. So b squared equals 4 on 6. So b equals plus or minus 2 square root of 3, which is different to what I have here. So which one is the correct answer? So therefore, contradiction for b values, therefore unable to express in the form.